Day 143, your basic 4-color carbon resistor. They're called carbon resistors because the main component inside them is some kind of carbon or carbon granule that gives rise to its resistance. Some of these resistors have 5 or 6 stripes. We'll be dealing with the basic 4 colors here. Sometimes ours will only have 3 colors. I'll explain that in a few minutes. They're usually brown and a little bit smaller than you see pictured here. And in the lab, if you have some trouble discerning the colors, because sometimes they're hard to see, the difference between brown, red, orange, call me over, I'll help you with that. And like I say, typically there's 4 colors, but it's important that you start from the right or the correct end of the resistor. The 4th color in our labs, or in reality, will always be either gold, silver, or missing. If you see a big blank spot at one end, that's the end of the resistor. Start at the other end. It's important you start from the right end. So if you see gold, silver, or a big blank, that's the last color on the resistor. Don't start there, start at the other end. Usually also the last one, the gold, silver, or none, well, or gold or silver, there's a bigger space between the 3rd color and that particular gold or silver band. So let me explain. You'll have access to these charts when you actually do the lab or on the test. I'm not going to make you memorize which color means what number, but let me explain now with the next example. So you have this in front of you. Let me go to the next page. Actually, before I go to the next page, since you don't have color notes, you might want to make a note of it on your paper here. The colors on this particular example, which I'll use for the first example. This first color here is red. Then we have orange. And we have yellow. And then silver. Alright, so let's go to the first example. Once you get going on these, you're going to find that they're pretty simple. You just look at the chart, and red is a 2. Red's 2. Orange is 3. You write those digits down. The 3rd color, however, does not stand for a particular digit. It stands for a power of 10. You look at the chart, yellow is a 4. That means 10 to the 4th. We'll be multiplying by 10 to the 4th, or adding 4 zeros to our digits to 2 and 3. The silver is 20% or 10% tolerance. I'll explain that in a second here. So bottom line, this particular resistor, the expected resistance of this resistor should be, you simply write down 23 or 23, and then 10 to the 4th or 4 more zeros. If you want to write it out longhand, 2, 3, 4. And it should be that many ohms, plus or minus 10%. I'll explain that in a second. But basically that's 230,000 ohms. Typically that will be written like this, 230 K ohms, plus or minus 10%. 230,000 kilo ohms, plus or minus 10%. Now, what does this 10% mean? Bottom line is you want to find 10% of the 230,000. I'll just take 10% of 230, do it on your calculator in your head, that's 23. So what this means here is that this particular resistor is 230 kilo ohms, plus or minus 23 kilo ohms, because 23 kilo ohms is 10% of 230,000. So I took the 10% of the 230,000. All right, so what does this plus or minus mean? Well, that means that this resistor in real life could actually be 230,000 kilo ohms, or 230,000 kilo ohms plus the 23,000, which would be the highest number it could be. Normally we subtract first. If I take 230,000 minus 23,000, you can do that in your calculator or in your head. 230 minus 23 is 207. So in other words, this resistor could be as low as 207 kilo ohms. That's the 230,000 minus 23,000, all the way up to 230 plus 23, which is 253 kilo ohms. So we would expect this resistor to be somewhere in that range. So that's the range of this resistor. That's the expected value, somewhere as I've circled right there. Here are a couple of other examples. So blue, red, brown, and then the fourth color, let's say, is missing. So blue, look at the table, is 6. Red is 2. You might even notice that the table itself is kind of like Roy G. Biv. Basically it is, plus some extra colors in there, but I don't expect you to memorize that order, but you'll see that pattern. And brown is a 1. That means 10 to the first power. And then none means 20%. If there's no fourth color, that means it's basically a cheaper resistor. A gold resistor, it's not real gold, it's the color gold. That means it's going to be closer to the expected value or the dead center value than a 20% resistor. But a 20% cheaper resistor would be cheaper to buy. Anyway, this resistor is supposed to be 620, so at 10 to the first means add 1 0. It should be 620 ohms plus or minus 20% of that. So I'm going to take 20% of 620, 10% is 62, so 20% is 124. So that's going to be a 620 ohm resistor plus or minus 124 ohms. So it could be 124 ohms higher than that or lower than that, so I'll subtract it first to get the lower value. And that is 496 ohms on the lower end up to 744 ohms on the high end. So it could be anywhere in that range of values, and in the lab we'll be coding them, decoding them like this, and then measuring them to see in fact if they are indeed within that range, within their. Alright, another example. Yellow is 4, black is 0, that's an actual digit though, not a power of 10 here. Blue is 6, that's 10 to the 6, so always write down the power of 10 for that particular third color. And then gold is 5%. So let's work with these numbers here. That means that this resistor should be 40, always write those two digits down, and then 10 to the 6th. So I can say times 10 to the 6th if I want, or put, well, let me just do that this time, times 10 to the 6th. And that's ohms, plus or minus 5%. So there's different ways you can express this in scientific notation. You could say 4.0 times 10 to the 7th, 40 times 10 to the 6th, or another way, the typical way that this one would be done would be 40 mega ohms, because 10 to the 6th is mega, plus or minus 5%. Mega is 10 to the 6th, that's million. Alright, so I need to find 5% of 40. Well, 10% is 4, so 5% is half of that, it's 2. In other words, this resistor should be 40 million ohms, mega ohms, plus or minus 2 mega ohms. So 40 million ohms plus or minus 2 million ohms. So it could be 2 million ohms lower, which would be 38 million. This resistor should be anywhere from 38 million ohms all the way up to possibly 42 million ohms if it's within its specifications, within that range. Alright, let's do some problems now backwards. In other words, given a particular measured resistance, what should be the colors on this particular resistor? The first thing you want to do is always round these off to 2 sig figs if you're dealing with these basic 4-color resistors, which these are the only ones that we'll be doing. So you take your number, your given value, and round it off to 2 sig figs. This here would be, the first one, part A, would be 470,000 ohms, rounded off to 2 sig figs. So then you just look in the table for the color, for the number 4. Number 4 is yellow. I'll just put a Y there for now, for yellow. 7 is violet, V. So I have yellow, violet. I have 4 zeros. So the 4 zeros together means 10 to the 4, which you look for the 4. That's yellow, 10 to the 4th power. And we're not given a tolerance here, so we're not going to deal with the 4th color. It could be gold, silver, or none. But I'm dealing with mainly here the first 3 colors that would be on this particular resistor. So it should be yellow. On the test, please write the colors out. Violet, yellow. And then it might have gold or silver if it has a given particular tolerance. So those are the three colors that should go on that particular resistor. Let's do two more examples. Once again, round off to 2 sig figs. In this case, the 1018 ohms rounds off to 1,000 ohms. Where this 0 right here, the second 0, is significant. That's a significant digit. For example, a 1, once again, is brown, so the first color is brown. Watch out with B. I'll just write it out, brown. The second one here is that 0. That's black, so that should go brown, black, and then there's 2 zeros left over, which is red. Let me write this out better. This one should be brown, black, and then red for the final 2 zeros there. That's a 1 kilo ohm, 1000 ohm resistor basically. Specifically if it's measured off to 4 sig figs, but you always code these things according to 2 sig figs. Let's do one more example. 34.7. Once again, first rounded off. 35 ohms. All right, the 3, look in the chart, is orange. I'll just write down the answer right up here. Orange. Look in the chart, 5 is green. And then how many zeros do we have after that, or how many powers of 10? We have none. So we need 0 zeros. That's black. So this resistor should be orange, green, black. So there you have it, coding and decoding carbon resistors.